All right, folks, we are going to take a look at solubility curves. Okay, now I know that this chart can look very, very daunting, but it's really not that bad. There's a bunch of lines, but we're only going to be focusing on one of these lines at a time. The x-axis down here is always going to have our temperature in Celsius, and our y-axis is going to have our grams of solute, which can dissolve in 100 grams of water at any given time. So that's what we're going to take a look at. Example 12-10 says that we have 40 grams of potassium chloride dissolved in 100 grams of water at 80 degrees Celsius. So I know that 80 is an important temperature for this problem. I also know that I have 40 grams of potassium chloride, and I need to know which line I'm dealing with. So I'm dealing with this line right here, my potassium chloride line. So what I want to do now is I want to find out where 40 and 80 meet each other, and that meeting point is right here. All right, my question asks, is this saturated, unsaturated, or supersaturated? Since my line is right here, I could technically add about 10 more grams of solute before I get to the saturation point. So therefore, I know that this is unsaturated. When I look at the next problem, I have 120 grams of KNO3 dissolved in 100 grams of water at 60 degrees Celsius. Well, for this one, I have 120 grams. I'm dealing with this line. I'm dealing with my KNO3 line. I have 120 grams, which is here, and the temperature I'm at is 60 degrees. So once again, I'm going to find out where these two lines cross. So I'm going to jog right on up this 60-degree line until I get to 120, which is right here. The line I'm concerned about is right here. And so I see that this is now above the line. It's above the saturation point, which makes this situation super saturated. My next problem, I have 80 grams of sodium nitrate. My sodium nitrate is this line right here. So what I want to do now is say, okay, well, if I've got 80 grams, so 80 is right here. If I have 80 grams of sodium nitrate completely dissolved in 100 grams of water at 10 degrees Celsius, which is here, I'm just going to jog right up this, and I see that my point is directly on the line. Since it's directly on the line, that means that I am saturated. So to recap, anything that is above the line, anything that's above whatever line I'm dealing with, is going to be supersaturated. If it's on the line, that means it's saturated. And if it's below the line, that means that it is unsaturated. So let's take a look and see what else we've got here. Let's take a look at 12-15. It says, how many grams of potassium nitrate will it take to saturate 100 grams of water at 50 degrees Celsius? When I go back up here, I know that I'm dealing with potassium nitrate, and at 50 degrees Celsius, I can come up and say, okay, let's see here, what did I want to know? How many grams will it take to saturate it? Okay, so I come up here, and I see that it's going to take me 80 grams to saturate potassium nitrate at 50 degrees Celsius. So I can just write that down as my answer. It's going to be 80 grams. The next problem is almost the same exact problem, but we're changing our amount of water from 100 grams to 300 grams. So what we're going to do now is I'm going to say, okay, you know what? I know that 80 grams will dissolve in 100 grams of water. So if that's true, I want to find out how many grams will dissolve in 300 grams of water. So all I have to do now is cross multiply. When I cross multiply, I'm going to get that x equals 240 grams. So that's how you solve these problems. Don't worry about the fact that there's all these lines and it looks real crazy and it looks real scary, because really, I promise, it's really not that bad. So let's go ahead and take a look at another problem real quickly on the next page down here. This one says if 50 milliliters of water are saturated with potassium chlorate at 25 degrees Celsius, um, and it's slowly evaporated to dryness, how many grams of the dry salt would be recovered? This is just a fancy way of asking the question, all right? So what we have, notice we have 50 milliliters of water. Well, water's density is 1 gram per milliliter. So if I have 50 milliliters, I know I'm dealing with 50 grams. Once again, though, I've got 100 grams, excuse me, on my y-axis. So I'm going to put 50 grams right down here. I know that I'm dealing with potassium chlorate, which is this one, at 25 degrees Celsius, which is right here. And so I'm going to scroll up and I see that I'm going to say that that's about 9 grams. Excuse me, I have 9 grams that would saturate 100 grams of water, okay? Because remember, this chart deals with 100 grams of water. And so it's going to take 9 grams to saturate 100 grams of water. So I have 9 over 100 equals, I want to know how many grams is it going to take to saturate 50 milliliters. So I'm going to do x over 50. Well, once again, I'm going to cross multiply. I'm going to get that x equals 4.5 grams. So now it asks me, if I let all the water evaporate out, how much do I have left over? Okay, well, all that's saying is, you let your water go, and so you're going to have some amount of salt left. So really, it's just saying how much salt is in there to begin with. So this still is going to be our answer. 4.5 grams of KClO3 is going to be our final answer. Let's take a look at one more problem. We're going to look at this next one down here, 12-22. It says 80 grams of potassium nitrate are added to 100 grams of water at 10 degrees Celsius. How much of it will dissolve and how much of it will still be solid on the bottom? So let's see what we've got here. At 10 degrees Celsius, I'm dealing with 100 grams of water, so I don't have to do any kind of changing. At 10 degrees Celsius, which is right here, okay, I'm dealing with potassium nitrate, which is KNO3. And so I'm going to move up here and I'm going to say, oh, at 10 degrees Celsius, it's going to take roughly 22 grams to saturate. Okay, so what that means is that 22 grams is going to dissolve. Well, if out of my 80 grams total, if 22 of those grams dissolves, then I'm going to say 80 minus 22 equals, so that's going to mean that 58 grams is going to be left over at the bottom. We're going to take a look at a lot more of these in class, so if these are not making a whole lot of sense right now, don't worry too much. I do want you to try as many of these on your own as you can so that you can make sure that you can bring your questions to class and we can try to figure out what we can. Thanks.